All right, gang, we're going to work on something that we learned a little bit about earlier this year, but we're also going to add on a step or two to it. Before we talked about a kind of a number that's called a prime number. Let's take, for example, the number, let me get my marker here, the number 41. If I factor that, I can break 41 down into, well, I can multiply 1 times 41. Those are the only whole numbers that I can use that will equal 41. Can't break them down any further. Okay? So if I go to my next spot, another page here, why don't we use, well, let's talk about composite numbers. Let's take the number, how about the number 24? I can break this number down a little bit more. Okay? 24 is a composite number. Why don't we break it down into, let's say 12 times 2. Well, I can break the 12 further down into 3 times 4. I can break the 2, I can't break the 2 down, so I just have to keep that. 3 won't break down anymore, so that's pretty much done. But I can break the 4 down further into 2 and 2. So I may as well just bring them along for the ride. This is a composite number because we can see that we've got more than one factor that equals 24. So it's a composite number. We've got more than 2 factors. It's higher than 1. So we're going to do something called prime factorization. Let's go to another window. Another window. There we go. Let's try that. There we go. Okay, in prime factorization, what we're looking for is we write the number as a product of prime numbers. It probably doesn't make sense to you, so I'll show you. Let's try the number 630. Okay. Well, I can break that down. Let's do it the easy way. I know I can multiply 10 times 63. That equals 630. And then if I break that 63 down, I can break that into 9 times 7. That equals 63. And then I can break the 10 down into 2 and 5. Well, I can break only one of those down even further. 3 and 3. So now I'm left with 3, 3, 7, 2, 5. Okay? Well, when I write the prime factorization, I start with my smallest number first. That'd be 2. How many 3's do you see in there? Okay, I see 3 of them. So I'm going to say 2 times 3 squared. Why did I say 3 squared? Think about that for a moment. Okay, now that you're done thinking, I did 3 squared because I have 2 3's in there. I'd like to save a little space, so I'll write it like that. My next number is a 5, and my next number is a 7. I've just done something that's called prime factorization. For this one, we've got a new word, monomial. Monomial. Why don't you take out your notebooks quickly and add this to the words that you need to know. We'll talk about monomials in a second. I'll give you some time to write that down. A monomial is a number, a variable, or the product of a number and one or more variables with a power. I bet that sounds really confusing to you. So in a moment, we'll take a look at what a monomial looks like. I'll give you a brief moment to write this down. I'd hit pause if I were you. Okay, let's take a look at what a monomial looks like. Let me turn my page. All right, I've got a monomial. I've got my whole number, 28. As you can see next to it, I've got a couple of variables. I've got an x, and then I've got a y with a power attached to it, y cubed. So 28xy cubed. I'm going to factor this monomial basically the same way we did with our other math problems, except I'm going to try something else. Instead of breaking it down and doing this 28, we can break that down into 4 and 7. I'm going to make a couple of changes. Allow me to get my eraser out. I'm just going to say, as I factor that out, I know that 4 can be broken down into 2 pairs of 2. So I know that 2 times 2 is 4. What did we multiply 4 times? I multiplied it times 7. This is just a different way to factor a problem. Well, let's see. What do you think I multiplied to get 1x? Well, I multiplied 1x to get x. And that's all I put for that. Now, how did I get y cubed? What could I have possibly have multiplied to get y cubed? Well, the answer would be y. Why, do you ask? Well, notice my number of y's in my answer has to match the number that my exponent shows. This is a monomial. I've got my whole number, my variables, and I also have an exponent. All right, let's start with something easy. Find all the factors that you can for 36 and 12. We're going to call this problems 1 and 2 on your work. For problems 3 and 4, I'd like you to tell if these numbers are prime numbers or composite numbers. I'll start with 100. Oh, no, I'm sorry, not 100. Let's start with 19 for 4, and we'll go with 84 for number 3. So you just have to write down is 3 prime or composite, and is number 4 prime or composite. I figured I'd give you a second look at this, so I'd like you to find the prime factorization for 180. We'll call this question number 5. I'll do 104 for you. Let's see, I could break this down in, why don't we say 8 and 12. I can break 8 even further down into 2 and 4. And, well, why don't we break 12 down into 4 and 3? All right, we can break, we can't really do anything else with that 2. So let's break the 4 down. We've got another 2 and another 2. And we can't really do anything with that 3 either. Okay, oh dear. Whoopsies. This is what happens when I do work at the end of the day. 13. Sorry about that. We're going to break this down into 8, and we're going to break that down into 13. So that also means that we can't multiply and get that. For some reason, I can't erase, and I don't know why. Well, it'll move it around. It's not hitting the erase button. That's odd. Well, let's try one more time. Well, sorry, that won't erase. So let's forget that I ever said attach the 4 to that. So that should be a 13, and this should be a 13. So if I prime factor that out, it would be 2 times 2 times 2 times 13. And there you have it. Come up with number 5 on your own. Okay, I'm going to factor this monomial out. I've got 21ab. Well, I know that I can break 21 down into 3 times 7. Well, the only other factors I have are times a times b. If I multiplied all those together, I'd have 21ab. That's it. That's the answer to my monomial. Easy, right? Let's look at another one. I've got 5xy squared. Well, it's 1 times 5 equals 5. I'm not even going to bother putting the 1 down in there. So I'm just going to say 5 times x because there's only one of them. How many y's do you think I should have? You were right. I should have 2. My number of y's has to match the number on my exponent. Okay, we'll try one more monomial, and then I'll let you do the factoring. Well, I've only got one whole number. I know I can break 1 and 3 down I can break 3 down into 1 and 3. I don't even need to bother with that, though, so I'll just say 3. Oh my goodness. I've got 6 f's. F times F times F times F times F times F. Looks like one of my 6th grade report cards. Ouch. You're going to have to do 6, 7, and 8 on your own. These should challenge you pretty well, but you should definitely be able to do these. Good luck. Oh, don't forget, when you're done, please make sure you put your name on your paper and you hand it in.